Hi, this is Todd with Land of Math. Feel angry? Perhaps mad? We got a video perfect for you. In this video, we're looking at the mean absolute deviation, also known as M.A.D. In this video, we're going to break it into three different sections. First, we're going to look at what do the words mean, absolute, and deviation actually mean in regards to math. Second, we're going to go through step by step, how do you actually calculate the mean absolute deviation? And there's a bunch of them. And then finally, we're going to use these three examples and we're going to compare their mean absolute deviations to each other and talk about the significance of each. All that's coming up next on the Land of Math.
When we're talking about the M.A.D., we're talking about three keywords here: mean, absolute, and deviation. So to help us understand this a little bit better, we're going to look at each of these words, the mean, the absolute, and the deviation. So the first word is mean. And this just comes from, we're talking about averages, like mean, median, mode. So this is just when we add up all the numbers, we divide by how many there are, and that's going to give us the mean. So in this example, if we add it up, we get 28. Divide by 4, because there's 4 numbers, we would get 7. So that's the mean. So that's where the word mean comes from in this mean absolute deviation. Absolute, this refers to the absolute value. Now, absolute value is just your distance of a number from 0. All absolute values are going to be a positive. So if we start to look at some of our different numbers, the absolute value of 4, for example, is just plain old 4. Negative 4, it's also 4. If we look at the absolute value of a 16, it would be 16. Absolute value of a negative 21, it's 21. So they're all positive numbers. When we're talking about deviation, there's a couple of definitions we can look at real quick. The action of departing from an established course or accepted standard, and the amount by which a single measurement differs from a fixed value such as a mean. So kind of like the norm. I like to think of it as a car. If I'm driving my car and I'm just driving it normal, like right between the lanes, there's no deviation. Now, if you're falling behind a car and the car's kind of swerving a little bit, maybe it's still staying in the lanes, we say there's a little deviation, kind of get your attention. But if a car is really out of control and it's going off the road, it's going just nuts, there's a lot of deviation there. So here's 3 examples where we can kind of calculate the mean absolute deviation. So example 1, here's a list of 6 numbers. The first thing we have to do is just add up all the numbers. So we add them all up, we get 180. Now, the next step is going to be to find the mean from mean absolute deviation. So we're going to take the 180 divided by 6, because there's 6 numbers, and we get 30. So the mean of this set of numbers is 30. The next thing we're going to do is we're going to take, and this is where it gets a little crazy, we're going to take the mean of 30 and we're going to subtract it from each of these numbers. So every single number in our original list, we're going to go minus 30 because that's the mean. And when we do this, some of the numbers are going to be positive and some of the numbers are going to be negative. And that's completely fine. So just subtracting the original number by the mean. Now, when we get to step 4, we're going to have to find the absolute value of each of these numbers. So when we talk about mean absolute, that's where the absolute is coming from. The thing about absolute value, as we already know, is each of the answers is going to be a positive. So the negative 10 is a positive 10. 20 is just going to be 20, and so on. So all the numbers are going to be a positive. Now, our 5th step is we're going to add up all these absolute values. So when we add these numbers up, we end up with 60 again. We're going to take this 60 and we're going to divide it by 6, because again, there's still 6 numbers in this list. 60 divided by 6 would be 10. So when we find the 10, that actually is our M.A.D. It's the mean absolute deviation. So that would give us kind of an idea how much the numbers deviated or were different than the norm, or in this case, the mean. When we look at example 2, same situation. We have 5 numbers this time, so we add them up and get 150. Divide by 5, because there's 5 numbers, so that'll give us the mean, which in this case is 30. Not a coincidence, it's the same as the first one. Next, we're going to divide each of the numbers by the mean, by 30. And again, you're going to see some of the numbers are negative, some are going to be positive. Then we're going to find the absolute value of each one. And when we do that, some of the numbers again will be positive, some will be negative. Once we get all our absolute values, We go ahead and we add those numbers up. So in this example, we have an 8. We're going to take the 8 divided by 5 because that's how many numbers there are. And we do that, we're going to get a decimal. In this case, it's 1.6. So the MAD, or the mean absolute deviation, 1.6. Our last example, we were going to do the same thing. So number 1, add up this list of numbers. We get 210. Divided by 7, because there are 7 different numbers. We do that, we get 30. So same mean for a third straight time. Subtract the mean. In this case, every single number is a 0. The next step is to find the absolute values. Well, the absolute value of 0 is going to be 0. There's no distance between 0 and 0. We then add up all these numbers. Well, this should be pretty easy. 0 plus 0 and so on is going to equal 0. Take the 0, divide it by 7 because that's how many numbers there are, and you get 0. So the absolute value is 0, or the mean absolute deviation is 0. In these 3 examples, you can see how the mean was the exact same for each of them, 30. But there was a vast difference when it came to the MAD. The first one had a MAD of 10, the second one 1.6, and the next one 0. So even though it would be easy just to say, well, they're all the same, they have the same average, there's differences. If you look at the first one, you can see how much deviation there is between all these numbers. There's a difference between 20 and 50. The second group, there wasn't as much deviation. And the last one, all the numbers were the exact same. So even though the means were the same, the MADs reflect that there was some deviation. Well, hopefully this was helpful to you. We'd love for you to subscribe and please give it a thumbs up. We'll see you next time on The Land of Math.